All right, welcome everyone. I just need for you to give me an example of a type of fossil fuel to let me know you're in the chat box. Awesome. Okay, so what we want to accomplish today, be able to explain efficiency, calculate some problems, determine what would potentially decrease energy efficiency, and then possible ways we can improve the efficiency of different appliances. We'll take a quick look at the homework from last night, see if you guys have any questions, talk through a little bit of efficiency notes, and then look at some practice problems. You'll need a calculator, a pencil, and just some scrap paper. All right, so these were your questions for homework last night. You guys were watching the video, The Incredible Journey of Oil. Are there any that you would like to go over before we move on? Okay. So efficiency, getting more from your money. So how can we essentially spend less and acquire more? So what is efficiency? This is going to be the effective operation as measured by comparison of production with cost as energy and time and money. So if you look at the diagrams here, efficiency, that's essentially the increase in the speed and the quality and the decrease in cost. So this whole idea of working smarter, not harder, is exactly what efficiency is getting at, in that you don't necessarily have to put forth more to get more out. So my question to you, if you guys could type into the chat box a little note, what is energy efficiency? All right, very good. Effective operation of energy, increasing speed, utilizing more energy with essentially less output. Awesome. All right. So this is going to be the measure of useful energy. An energy efficient appliance maybe came to mind. There's going to be this little logo here. That just means it meets a certain standard of efficiency, and it's approved to be a low energy consumptive appliance. And that's primarily what you see on the market now, not so much the older versions where they were a lot more consumptive. Can you guys see that? Did I click over? Okay. All right, another little question for you. So how would you vote on this question? Should the United States greatly increase its emphasis on improving energy efficiency? And you've got two options with a little description key in where you stand. All right, so Becca and Sydney agree. Interesting. Good point, Hannah. Okay, so we're a split choice here. So Becca and Sydney say if we could create incentives, this would then drive different corporations and companies to move towards efficiency, but we have a divide here with Julie and Hannah. Does anybody want to chime in with audio for their perspective? All right, let's see. So one thing we have to take into consideration in looking at energy efficiency are properties surrounding energy. And one that determines input and output is the second law of thermodynamics, which you maybe have seen in another course. This states in any spontaneous change, the entropy of the universe must increase, which means that the quality of energy deteriorates gradually over time. So there is this loss, not in the sense of it kind of being destroyed, but in the sense that it is no longer in a usable form. So entropy is the measure of randomness or disorder in a system, and is also a measure of unusable energy within a closed or isolated system. So this happens all the time with our appliances and anything else that we use that's energy intensive. Some of the energy is not going to be directly converted into, let's say, mechanical energy. So my question before we move on is, any thoughts on where the energy goes? When we say energy is lost, what is it lost to, or in what way? Think about an appliance at home, or your car, your metabolic energy, chemical energy in your food. A lot of it's lost in some way. Okay, so Becca's getting at something. Very good. So it is lost in the form of heat. So we aren't going to be able to harvest 100% of the energy we're putting in. When we metabolize our food, yes, we use that for cellular energy. We also use it for mechanical energy to move our bodies, but we also use it as thermal energy in the form of heat. All right, so during a chemical reaction, a certain amount of the energy is lost in the form of heat. Some examples that we saw there, or that I was giving, such as appliances, they're going to give off heat. Even if, think about a refrigerator. The goal of the refrigerator is to make things colder, but as a result, you have to put out heat to be able to do that. All right, so how do we measure efficiency? So efficiency of a product can be measured by the output divided by the input times 100 to get that percentage. And we're going to practice this on the next slide. So output is the mechanical work or energy, usually measured in watts or joules, and then the input is the quality of work or energy, and it can't exceed 100% because you can't get more out than what you're already putting in. Okay, so here are the practice problems I want to work through. So the first one here. How much would you save by replacing a 100-watt incandescent light bulb with a compact fluorescent bulb over the 12,000-hour lifetime of the bulb and the electricity cost of 8 cents per kilowatt hour? So how would we set this up? Let's see here. Draw, click. Let's do black. So you have to figure out where you're starting and where you want to end up.